Hi, my name is Polina. I'm a machine learning engineer in SaltAI, and here is my video walkthrough of our new Node Pack functionality. SaltAI Documentation Tool Pack was designed for producing automatic documentation for different ComfyUI components. The core techniques we used were large language models, especially OpenAI ones, and Retrieval-Augmented generation patterns implemented in Llama index. We documented node packs available in our system using only the provided tool pack, and this documentation is publicly available on our website, so you are always welcome to check it out and see the quality and format. Now let me briefly guide you through the pipeline that was used to create this pack. So let's say we have a pack of nodes that we would like to document. Firstly, we split this pack source code into chunks and embed them using special model. It basically means that we are creating vectorized compact representation understandable by language model and allowing us to perform vector similarity search. Next, for each node, we retrieve relevant pieces of embedded code and passes to language model as context, along with a request to document this node according to the provided JSON schema. JSON schema contains multiple entries such as node docstring, input parameter docstring, input parameter data type, and so on, each having specific prompt with instructions for language model. After language model returns some output, we evaluate it also by language model against a set of predefined questions, especially emphasizing parts that are the most important or most hard to document. We compute evaluation total score, and if there are some problems in the response, we refine the original query with validation feedback and repeat the request. We do this until we either reach number of attempts or we get the result that we consider satisfactory. After that, we explore big database of Comfy pipelines and search for the nodes that are commonly used together with this one in pipelines. And final step is some post-processing and filtering entries that were detected incorrectly and so on. Now, let me show you the nodes that were implemented inside of this pack. First node is model loader node, where you can select language model by name from ones available in Llama index. Please note that each model has its own price for execution, and you should check it out on official website before running the pipeline. Next parameter is temperature, which means how strictly we want the language model to follow the prompts, where 0 means very strictly and 1 means that we allow more free responses. I recommend setting it to 0 because even in this case, model sometimes ignores the prompts. And last parameter is embedding model, which is the model that we are going to use for creating this vectorized embedding database. This step is actually pretty cheap compared to language model calls, so don't worry about that, but different embedding models are good for different things, and OpenAI recommended to use this exact model for tasks of code analysis. Now let's go to the most important nodes of the pipeline, which are document node and document pack nodes. Those are actually pretty similar, apart from the fact that document pack nodes work with the whole pack of nodes and document node process one single node. In both cases, you can select node or pack name from the ones that are currently loaded in your system and start documenting. Parameters, chunk lengths, overlap, and max chars are about the process of creating embedding vectors for the code database, and here are the parameters values that I consider the best. Number of retries is number of attempts our pipeline is going to make in the process of querying and evaluation, and until we return whatever was the best response. Top K parameter means the number of context vectors that we are going to pass to language model as context about the current node. Please note that if we set this parameter too small, model may have not enough context about the node and hallucinate. And on the other hand, if the parameter value is too high, note that these context vectors are actually tokens for which we pay to OpenAI, so it's important to find balance between accuracy and price. Let me show you how the pipeline stores outputs. So everything is stored inside of cache dir, which has two subfolders. First subfolder is indices. Index is this vectorized representation of code base. We store one index per node pack. We have subfolder, which is basically a concatenation of all parameters used during the embedding process, so that you don't regenerate vectors if you already launched with these parameters once. If you change different parameters, there will be created another folder. Documented nodes are stored in the same manner in the folder documented nodes. A parameter line return outputs as JSON files sorted by packs. So we have one folder per pack, and in this folder we have one JSON per node, looking like this one that I showed you. Also, optionally, you can use converter to create markdown representation of this JSON documentation to be able to look closely at it or even push it to your GitHub. Note that you are welcome to change the converter function, and this is just something that worked in our case. So now two last parameters make more sense. The generate parameter set to no. The default value means that we won't regenerate anything by default if it's already there. We generate documentation only for nodes that are currently missing in cache dir. But if we want to regenerate either documentation JSONs or everything, we should set this parameter to doc or index and doc correspondingly. Failed option means that we generate documentations only for nodes that are not documented yet, and for nodes that were documented but there was some error or mismatch in the previous documentation. And save markdown parameter means whether we want to save markdown version of documentation. So the pipeline returns string output, which is debug information about pipeline execution. It has three entries. First is max score, which is score given by evaluation model, and given that it's language model, not deterministic algorithm, this score can be considered not very seriously sometimes. The second parameter is more important, number of skipped fields. There are cases when language model misses some of the JSON schema entries. For example, it fails to produce documentation for some of output or input parameters. In this case, we deterministically detect this mismatch and add it to documentation, but with value unknown. And this parameter is corresponded to the number of such problems in the documentation. And nodes with errors is worst case scenario. It means that documentation wasn't produced at all, and you will see the error message in the results in JSON file. So this debug info can be actually available per node in this private JSON schema entry. And the last thing that I wanted to show is Phoenix logs tracing. Sometimes when you experiencing problem with your pack, or you suspect some edge case, or you just want to know more about language models, you would like to see the intermediate debug outputs of language model calls. In this case, you can set environmental variable enable Phoenix login, please see readme for details, to true, and in this case you can open this, and there you will see all the information about internal language model calls. So all the prompts, all the responses, all the outputs will be there, and you can detect any possible problems. So I think that's all. Thank you for your attention. I hope you will enjoy using our platform and our products. Bye.